For recording to start, I want to. Okay, I would like to welcome everybody to today's session. We hope you enjoy the session. We only have a few small house rules for today. We would like to ask everybody to please keep your cameras muted, to keep the to save data and bandwidth. Also, to mute your microphones to keep all the background noise to a minimum. If anybody has a question at any point in time, please feel free to raise your hands, and I will hand over to the presenters for today. Thank you very much.
Thank you, Jasper, for this, and welcome to everyone who's here. We're going to talk to exploring industrial engineering. My name is Habu Mokotwa. I'm from the Department of Industrial Engineering, based in the School of Engineering at UNISA, and I'm a lecturer, researcher, also an associate chair of research in the department. I'm joined by my good friend and colleague, Professor Ramdas, who is here. He will introduce himself just now. My background, I've only been in academia for 3 years, but before that I worked in corporate for like 20 years or so. So I started with UNISA in 2019, in April, the 1st of April 2019. And so I'm going to give Prof. Ramdas an opportunity to introduce himself, and we are going to hit the ground running. Prof. Ramdas, to you, my friend.
Thank you so much, Kabo. Much appreciated. My name is Professor Ramdas. I have just to give you a brief background about myself. I have been in industry for approximately 20 years, which means giving you some information regarding the industries. I have been in the clothing industry, the textile industry, automotive industry, electronics industry, and then in 1999 I joined UNISA, or the then Technicon SA. So I was a lecturer, and currently I am a professor in the Department of Industrial Engineering, in the School of Engineering, in the College of Science, Engineering and Technology at UNISA. So that gives you a little bit of background about myself. I hand over back to Cabo. Thank you so much.
Thank you, Prof. I'm going to ask you to give some insights on Engineering Council of South Africa just now, but let me share my presentation first. So let's see.
I hope you can hear us loudly and clearly.
Yes, I can hear you guys from my side.
Thank you.
In the
Yes,
presentation.
now we are better, but for the professor, it was not clear.
Thank you. Okay. So we are going to talk to you guys about industrial and systems engineering. I'm not sure, can you all see my slides here? No?
Yes, I can
Yes.
see the session.
Yeah. So this is divided into 4 units, and today we are talking to introduction to industrial and systems engineering profession. Myself and Professor Ramdas are not just academics. We worked in industry before. He worked in the clothing sector and electronics sector. I worked in research. I worked for the CSIR. I worked for Volkswagen in the Eastern Cape, where we assembled cars. I worked for the post office for many, many years. So we are going to share with you the real issues in industry from an industrial engineering perspective. I'm going to do a screen slideshow just now, but before I do that, our agenda, we are going to talk to what is industrial and systems engineering. We're going to speak about entry requirements, and we're going to speak about typical modules. We don't have enough or many slides, but the few slides that we have, we can take even 2 hours talking to the slides because there's quite a lot of information there. But we are going to finish in time. We are supposed to finish at 4. So we'll do the presentation quickly, and then before we do that, we'll give some background, then do the presentation, then we will then have questions and answers. But maybe before we do the presentation, can I share? I want you to listen to this YouTube video. Then as soon as it finishes, then we can start with the presentation itself. Just tell me. Can you all hear it? Yeah?
No, we can see it, but we can't hear it.
Can hear.
Yeah, we can't hear it.
Sure.
I think it's maybe did you enable the sound to include the sound of the computer when you started the screen share?
Let's check that quickly. So
if you maybe unshare and then reshare your screen and then enable sound while you are resharing.
let's unshare quickly. Share.
And then just when you press on share, there is a button that says include computer sound. Just select that one and it will automatically share the screens on the computer sound.
Okay. So sound. Okay. Let me just take off because I was using my microphone. So maybe that's why it's giving me problems. Let me just take it off and then use the computer sound. Let me just disconnect my Bluetooth device. Yeah? And that's the reason why. Okay, then we share. Yeah, it allows me now. So yeah. Okay. Thanks, Caspar.
My pleasure. We can see the screen again.
Can you hear anything?
Yes, we can hear from our side.
Industrial engineers don't make anything new per se. They just take what is present and make it better. So people ask what industrial engineers do because they're familiar with aeronautical engineers working on building planes, civil engineers constructing bridges. And I would say what industrial engineers do is work alongside them, improving their processes, helping them do whatever they do better, more efficiently, more cost effectively, increasing safety and increasing user satisfaction.
It offers all kinds of classes. The diversity of classes that includes from human factors to operations research, simulation, plant layout, material handling, all kind of stuff that make you think of the system, the whole picture, and making things better and more efficient. I think that's really what I feel exciting about ICE.
Some people say that industrial engineers are the glue that holds a team together.
Both of my parents are engineers, and they really inspired me that engineers can make a difference to the world. In the lab, we're designing for better car systems, including voice interfaces and collision alert systems. And those can save people's life just from less distraction. People like to engage with voice interfaces in car when they're driving because they perceive it to be safer. And the truth is, drivers are distracted when they're using voice interfaces. So we're trying to design a better voice interface so that it requires minimum cognitive workload.
So I've been doing research with the Navy through the University of Washington. So the Navy is looking at getting 3D printers onto ships. That would be incredible if we could, if a part fails and you could print it on the spot. This summer, I'm working at Boeing, and we're working along one of the flight lines. They're incorporating a mid-flight refueling system, so I'll be looking over that process, making sure the whole system is going to work from start to finish.
I'm always trying to do things efficiently. I'm always trying to make things better. And I think that's what I'm going to be doing in 5 or 10 years. No matter where I apply it, no matter it's manufacturing, no matter it is research, data analysis, or even in the design per se, I will always try to make things better. Nothing is perfect, and we can always improve it.
Thank you for listening. I'm sure you have listened to the video, and we are going to now start. You have now a brief understanding of what industrial and systems engineering is all about. It's about efficiencies, about improving, making things much better, more efficient and less wasteful. Maybe before I go into the presentation, Professor Ramdas, can you maybe just give, for 2 minutes, give a perspective in terms of the profession itself? Can speak briefly about SAI. Maybe 2 minutes is not enough, maybe 5 minutes. Speak about SAI, speak about the Engineering Council of South Africa, and maybe Council for Higher Education in this whole process of training industrial engineers in universities. Prof, to you, and then as soon as you are done, we will go into the presentation itself. Prof Ramdas, to you, my friend.
Thank you so much, Cabo. So as you listen there, industrial engineering, it can work simultaneously with other engineering disciplines as well. So what is industrial engineering? Basically, what do industrial engineers do? And that's what we're going to be covering now. But let me talk to you a little bit about the bodies that basically govern us. So one of the main bodies that has been gazetted by the government of South Africa is ECSA, Engineering Council of South Africa. Now, the Engineering Council of South Africa basically evaluates, the curriculum that we provide to our students to ensure that when our students graduate, they are able to achieve graduate attributes. And graduate attributes have been implemented, I think, 2 years ago, which basically ensures that the outcomes of a module has been, practiced well and learned well by the student. So when the student writes an examination or a test or whatever the assessment the student does, the student needs to be proficient in achieving that graduate attribute. So from the ECSA side, basically they evaluate us, from time to time to ensure that, whatever we do is above board in terms of curriculum and also in terms of our engagement. So they basically monitor our engagement with industry, our engagement with other stakeholders. And we must remember that ECSA is internationally recognized. So we have several accords with a number of countries like the US, Canada, Australia, and so forth, where our curriculum should be or is in line with the curriculum that is presented in universities across the world. So EXA basically is our main stakeholder in managing the curriculum that we provide and in ensuring that our students are well equipped when they basically are out there in industry, or even if they open their own business, they understand that the principles of graduate attributes has been achieved and maintained and can be practiced by themselves. So in addition to that, we also register with the South African Institute for Industrial Engineers, which is a voluntary association, VA, and all industrial engineers with a first qualification or in the process of a first qualification can basically register with the SAI. And at SAI, you get exposure and you get networking opportunities, and even you are able to see the vacancies that have been posted on their website in terms of recruitment of industrial engineers. So SAI it's basically the Southern African Institute for Industrial Engineers, and they have meetings from time to time to ensure that as well as maintaining our curriculum, ensuring that all the universities are speaking the same language, the same voice, and also ensuring that students and as well as practitioners are well engaged. So they have conferences that you can attend, they have meetings that you can attend, but there is a council that governs it, there is a president, there's a council, and so if you're doing industrial engineering or even any other engineering discipline, there are voluntary associations associated with that specific discipline. So EXA, the South African Institute for Industrial Engineers, and then let me talk a little bit about the Council of Higher Education. So the Council of Higher Education basically accredits our qualifications. So we as a university develop a curriculum. We develop a curriculum with research that we have, with looking at what other universities are doing, and we basically present this curriculum through to the Council of Higher Education. So the Council of Higher Education strictly evaluates every module that is in that curriculum to ensure that whatever is being done is above board and is correct in terms of our engagement with our students. So that is as far as curriculum is concerned. So they basically have audits. So the Council of Higher Education basically evaluates all higher education institutions to ensure that whatever they are presenting is of the right standard, of the right quality. Okay, so we spoke about the Southern African Institute for Industrial Engineers. We spoke a little bit about EXA, and remember, you are welcome to just go into Google and type SAIIE. You will find SAI. You can type in ECSA. You will find EXA. And if you also type in CHE, Council of Higher Education, you can go and read more information about them on the respective websites. So these are some of our main stakeholders that ensure that the quality and standard of our programs are in line, and basically in terms of the graduate, in terms of the transformation process and the graduate that we transform in this 3-year or 4-year duration of the program. So that's about it there in terms of our external bodies. And I think it is very, very important for us because, I mean, the Council of Higher Education endorses our qualification. If our qualifications are not endorsed by the Council of Higher Education or the Engineering Council of South Africa, then we are not allowed to offer this qualification. So that is how important it is in terms of engaging with our respective stakeholders. And it also goes through to government as well, to show government, this is the quality of the graduates that we are producing, which ensures that whenever our student, is, registered with EXA, there's a registration process with EXA. The interviews ensures that the quality of the graduates that are interviewed are in line with the respective curriculum. I'm going to stop there, Cabo. Thank you so much.
Thank you, Prof, for that background, which is very important in terms of the profession itself, in terms of the quality standards and also accreditation bodies. Can everyone see my screen? So we are going to, is it fine?
Yes,
Casper?
I can see the presentation.
Yes.
Thank you. Okay, so we are going to go straight into, we spoke about, we are going to talk about what is industrial and systems engineering. We're going to talk about the entry requirements. And lastly, we're going to talk about typical modules. We say that industrial and systems engineering is a branch of engineering that is concerned with the design, installation, and continuous improvement of integrated systems of people, materials, information, equipment, and energy. And it draws knowledge and skills in mathematical, physical, and social sciences, together with principles and methods of engineering and analysis and design in order to specify. It's important to specify products in order to predict how these products are going to perform, and also assess the outcomes that will be attained from such systems. And we have a small graphical representation of all that statement that we had above there. So the first one here will be the design. This one is installation, and this one is continuous improvement. And this DI squared IS, don't think is a formula. It's just design of design, installation, and improvement of integrated systems of, we said people, we said material, we said information, we spoke about equipment, and we spoke about energy. So the field of industrial and systems engineering is about design of these systems and integrating these systems so that we can have better systems, more efficient systems, be it transport systems, be it electrical systems. If you are designing and you saw from the video, industrial engineers work, and as Prof. Ramdas alluded to it, industrial engineers work with other professions. If it is electrical engineers designing a power station, industrial engineers must be involved so that we can see how we can better make their processes more efficient, better distribute the energy so that you reduce energy losses as you transmit from power stations to the household, things like that. So the field of industrial and systems engineering is quite a broad field. And in Learning Unit 2, you will see where you can work as an industrial or systems engineer, or industrial systems engineer, or an industrial engineer. It is broad, and you can work everywhere where there are people, systems, and processes. You fit the, be it mechanical processes or manual processes or whatever. Industrial engineers are there to optimize and also design better systems. And we will go back to that. So let's now talk to the issue of entry requirements. If you want to study industrial and systems engineering, you need mathematics and not mathematical literacy. And I think it is important where, especially in high school, when students choose their subjects in, I think is it in grade 10 or something? It is very important to choose the right subjects there, because if you choose mathematical literacy and you even have a distinction in mathematical literacy after in matric, you will not be allowed to study engineering with mathematical literacy. You will need pure maths because industrial engineering is grounded on mathematical principles, physical science principles, be it electromagnetism, be it mechanics, because you're going to do a lot of forces. When you design jigs in factories, you deal with a lot of these things. So those two things are very important. Maths, in terms of pure maths, and mathematical science, be it physical science. And we just said it's FX, which stands for the mathematics. E is equals to MC squared, standing for physics or physical science, because physical science is both physics and chemistry. It makes physical science. And that gives you the key to be able to get access to study industrial and systems engineering in university. So it is important for those in high school to do well in maths and do well in physical science. And maths, sometimes we tend to think maths is a very difficult, complex subject, but with practice makes perfect. As you practice, you understand the concepts. You can have any way these things will be brought, but you will get it right because your conceptual basics are correct. Typical modules that one will do when you and this is modules from first year to fourth year. I didn't say Maths 1 or whatever, but I just wanted to give you context in terms of which subjects or modules. In university, we talk about modules, and maybe in high school, we speak about subjects, but it's typically the same thing. So these are the modules or the subjects that you'll be doing in order to finish your four-year degree or a 3-year diploma. You are going to do a lot of electrical engineering at the basics in first year, because you need to understand those concepts of electrical engineering, be it magnetism, optics, and things like that. You are going to have to do engineering mechanics, which is grounded on physics. You need to understand how forces work. You want to design systems that are stable. You want to design something that is going to be a safety hazard to people who will be using your jig or your fixture or whatever design that you come up with. We cover engineering production technology because industrial engineering and systems engineering graduates also work in production. How do you optimize and work with machines such as your CNC machines? How do we optimize them? How do we design them? Because you also need to be able to design these machines. We know that it might be the work of maybe mechanical engineers, but you need to be working with mechanical engineers so that when they design, your designs are more efficient and more effective. And industrial engineers are best placed at ensuring that. Engineering work study, where you, I think Prof will talk more to engineering work study. He worked in the clothing industry as an industrial engineer there, doing work study quite for a long time, where we want to balance the line and make sure that everyone has equal amount of work in the production line. How do you make sure that you analyze and give people breaks, because people are not machines, they cannot work 24/7. How do you allow for breaks and things like that when you design the work? Engineering mathematics, very important. Manufacturing technology, engineering management, because when you are an industrial engineer, you will be interacting with employees, managers, even top echelons of power. So you need to be able to, manage those relationships. So engineering management gives you that flexibility and ability to be able to engage as a manager. Mechanical engineering design, very important also. Solid mechanics, operations research, simulation. You saw that lady, she was driving a car which is stationary. That is simulation. And there's a reason why we do simulation, because simulation gives you a better way to test systems before you deploy them, because you are able to see all the stresses and the failures, and you can fix the failures before you design the actual product. You can imagine designing an aeroplane, and while it is mid-air, we are simulating there, then it goes down and we've got 100 passengers there. Simulation gives us an opportunity to design while at no risk or zero risk. Advanced manufacturing, industrial accounting, you need to understand accounting, you need to understand costing, because you'll be doing a lot of costing when you do a big project or a big design. There are costs involved. How do you optimize the cost? You need to understand statistics. There's industrial engineering statistics, quality management. Every product that you do or every service that you do, quality must be embedded into it. Issues of facility planning and materials handling. How do you design such things, such as factories and things that you are going to use to do material handling, be it your forklifts and things like that. Environmental engineering is very important, because nowadays the environment is very important. When you design, whatever designs that you come up with, you must take into cognizance the environmental impact. Engineering entrepreneurship, how do you prepare engineers so that when they graduate, they don't depend on someone giving them work, but they are able to develop their own work, develop their own ventures, and be able to employ other people. Supply chain management, logistics engineering, maintenance engineering, production and systems engineering, information engineering, engineering quality management, research project. You need to be able to do research so that when you are doing your degree and you want to do your masters, we do mostly research. So you need to be able to start understanding how to do or conduct research, management of technology, industrial engineering design, enterprise architecture, design for manufacture, statistical techniques for science and engineering, engineering work study, maths again, or engineering management comes back. It might be engineering management 2 or 3. I did not list the modules in terms of 1, 2, or 3 in terms of their levels, but broadly. Prof. Ramdas, can you maybe add a thing or two in terms of what I just said now?
Yes, Kabo, thank you so much. So I want to talk a little bit about competitiveness and productivity. These are very, very simple words, but we need to understand what they mean in an organizational setting. So let me give you 2 examples. When you look at competitiveness, let's say you are an athlete and you have someone basically, challenging you and winning, and you are basically second or third. So how do you develop yourself? So if you put it in an organizational context, you as an organization want to be better. You are competing with someone. What would you do to look at, how can you, develop yourself? So basically, you may look at, more exercise, more training. How do you better yourself so that you are able to compete with the person that is, winning all the time? So it's basically internal preparation. And internal preparation, it takes a while, where you may be looking at a person, for example, a dietitian, so that he enables you to eat the right foods that can give you the energy that is required to be able to boost you to be able to beat your competitor. But if you're looking at, an organization, I gave you a simple example where you're competing with someone else. But let's look at 2 very, very simple organizations. If you look at, for example, Coca-Cola, and then you look at Pepsi, they're basically competing for business with one another, because they both want to stay in business. They want to make a profit. They want to ensure that they're making a reasonable, amount of profit to be able to survive, because they have a lot of overheads that they need to meet. So they are always competing with others, seeing, what is this guy doing that what am I doing? And they always benchmarking between themselves to see how can I always remain competitive. And industrial engineering is one of the techniques that can be used to basically measure and ensure that you are able to be competitive. And that is why we use the word continuous improvement. You are able to improve yourself continuously so that you are able to keep abreast of both, national competition. When I say national competition, means that there may be a lot of other cool drink manufacturers within South Africa. How can I be better than them? Then another context is, if you're looking at productivity, what is productivity? Productivity is a ratio of output to input. Let's say, for example, you want to open up a shop at your home. I'm going to use a very simple, you want to open up a spaza shop at your home. So there's a lot of input that is required. Input, process, output. So your input will be, your input will be, you need maybe a shelter to basically display all the items that you want to sell. Input, so all the money that you outlay, the goods that you buy, the electricity that you use, the people that you may have working with you, all these are input. What is the process? The process is you are serving someone. You are basically selling that product at maybe 10 cents more, 20 cents more, whatever the case may be. You are selling the product. So that is the service that is required. So if you give good customer satisfaction, you're going to get more people coming in. And that is where quality comes in. And quality also comes in when people are evaluating the quality of your goods that you are selling to them as a retailer. Yeah. So that's, looking at productivity. So basically, I spoke about input. So that is the input. You have the process of selling, and then you have an output. When you sell your product, you basically have, at the end of the month, you need to reconcile what have I sold and what is the income coming in. So you measure productivity by input, measuring your input as a ratio to your output. So if you put in 10 Rand and you're getting 5 Rand back, it means your business is not doing well at all. You have a serious problem. You're going to close down tomorrow. So, but if you put in 10 Rand and you get 20 Rand, then there's something now. I have doubled my money. So basically you are able to measure input, process, output, and you are able to maintain your status in terms of how can I now be competitive? There are 10 spaza shops out there. What can I do differently that will enable me to stay in business, to improve, to thrive, and to basically service my customers? I'm going to stop there, Kabo. Thank you so much.
Thank you, Prof. Ramdas. Yeah, so maybe what we can do now is to take questions and comments from the participants. I'm going to stop sharing so that I can see the hands as you raise them. But I think the crux of the matter, as Prof alluded to it now, and as alluded by the presentation and the YouTube video, industrial and systems engineering is about improving systems, design, installation, and improvement of systems so that the systems can be more efficient and safer. And hence in industrial engineering, you do all kind of modules, be it from the soft side, be human resources or accounting or costing, to the hardcore, which is engineering, mathematics, design, statistics, and things like that. So I'm going to pause here, and then we can take some questions or comments from everyone if there are. Before we close, we've got 7 minutes to go, so I think we still have enough time to go through the comments and questions. Are there any questions or comments from participants with regard to the field of industrial and systems engineering? And this taking into consideration, this is just learning unit 1, which is the introduction to the profession. And we have not yet gone into the tools, applications, and things like that. Any questions or comments?
If anybody has a question, please feel free to raise your hand, or if you have some mic problems, you can put it into the chat area.
Thank you, Casper. Any question, comment?
I can't see anybody. If you are struggling with the hand function, you can even unmute if you want.
Casper, I suspect that the presentation was loud and clear, and maybe hence there are no questions. But we'll appreciate your feedback and have your comments so that we can make sure that we improve also on the Learning Minute 1 for next time. But if there are no questions or comments, I'm going to thank everyone for making time to attend. Or Prof. Ramdas, your hand is up. Go ahead, my friend.
Thank you so much, Cabo. So I do not know how to address you, but I'm going to address you as students. Look at yourself as an individual. You are an organization. I mean, if I take parts of your body out, you're not going to function. So those parts of your body are your departments in an organization. So so if you are ill, let's say, for example, you have a headache, you're not going to, go to a psychologist to sort your headache, your headache out. You're going to go to the doctor. The doctor will ask you what is going on, and he'll give you the necessary medication. So in effect, if you compare yourself now to a factory as an organization, it has all these departments that work, work hand in glove with each other. Each one is supporting each other, and so each body part or each system in your body is supporting each other so that you can function optimally. So if there are different tools or different medication for different problems. So is industrial engineering. If there is a certain problem in an organization, the person will go and look at what is the problem. He will analyze. Basically, in engineering, you define the problem. If you do not understand the problem well, you will not be able to solve the problem. So you need to be in such a situation where you are able to define, you need to measure, you need to analyze, you need to improve, and you need to control. So that is part of DMAC, which is Six Sigma. And we will talk about about Six Sigma and lean manufacturing and so forth at a later stage. But just to give you, how do you optimize yourself, your resources? The Lord gives you 24 hours every day. How do you utilize those 24 hours? And I know a lot of you want to play games, you want to do this, you want to do that. My suggestion for you is you need to think strategically. You need to use your resources, which is time. You have 24 hours every day. Try to utilize that so that you can be number one in your class. Because if you utilize those resources well, and you are able to learn the work well in your class, means you are being productive, and then you can be you can be the number one person, and everybody will applaud your hard work when you complete your qualification, which is your metric or your assessments that you do. So I'm giving you this as a simple example. You can improve yourself. You can take this home and improve yourself in terms of, I'm not going to waste. And one of the aspects about industrial engineering is the elimination of waste, because waste costs a lot of money. And once you try to eliminate or reduce the waste, you have more time available, and you have more time to make yourself to improve what you are doing, as a simple example. Thank you so much, Kabo.
Thank you, Prof, for that. And yeah, I think that example just, it actually strikes home because we all have systems, as in our bodies. You've got your nervous system, your internal system, your internal organs, and all those things. But how do we ensure that they work efficiently? Is by we eat right, we exercise, so that we can perform better and better. So we are industrial engineers in a way. So if there is no other comment or question, I'm going to close this session and thank everyone who attended here, and also thank Prof. Ramdas, and thank Corne, not Corne. Corne is not here, but Caspar. Thank Caspar for arranging this particular presentation. And we hope when we do Learning Unit 2, there'll be more people so that we can share the message. We can avail the slides, we can send them to Caspar, who can distribute them as he wishes to everyone. Thank you, Prof. Any last words? Then I can give to Caspar to close. Prof. Ramdas, your parting words.
Thank you so much. I would like to take this opportunity to thank every student that he has made his or her time available to be here so that he could gain some knowledge, or hopefully gain. If you learned one thing today, means you have learned one thing. And every day, if you learn something new, in 365 days, you would have learned 365 new things. Thank you so much, Kabo.
Thank you, Prof, for that. And Caspar, thanks for organizing this. Back to you, Caspar. Then you can do the honors and close the session. Thank you.
Thank you so much to our presenters for today, and thank you for everybody for showing up for today. I wish you all a very nice day. It's a very cold day here in Witbank, but I hope it's very nice warm wherever you guys are. Thank you very much, and then we will see each other tomorrow afternoon again, same time, same place. Thank you very much.
Thank you, and goodbye.
Bye-bye.
Thank you. Bye-bye.